Hello, hi everyone. Welcome to the Student the Brand. This is your sir. Today we are going to discuss about scalars and vectors. Vectors or scalars, I think. Okay, so CBSE grade 10 physics, grade 11 physics, not grade 10. CBSE grade 11 physics. Okay, so vectors. So we'll completely write vectors. I'll write vectors. Okay, so heading is vectors and scalars, but still we are completely discussing about vectors topics. Okay, vector topics. So that's why I'm mentioning vectors. CBSE grade 11 physics. Okay, so normally you can see quantity. Quantity is nothing but quantity. Quantity is nothing but, so it gives the answer for how much or how many. If you go to shop and ask the shopkeeper, so I need rice. Will he give immediately rice? No, he will ask two questions. How much you want? Second question, for how many kgs you want? First, for number one is for how much? For how much money? For how much you want? Or for how many kgs? How many kgs you want? Two questions he will ask. Yes or no? Yes. So that is quantity. It tells the answer for how much or how many. It tells the answer for how much or how many. That is called physical quantity. Sorry, quantity. So coming to the physical quantity, the quantity which can be measurable. Physical quantity. So the quantity which can be measurable is called physical quantity. The quantity which can be measurable is called physical quantity. First of all, quantity. Quantity means it tells the answer for how much or how many. It tells the answer for how much or how many. Physical quantity means the quantity which can be measurable. The quantity which can be measurable. Suppose if you take mass, we can measure. Okay. And speed also we can measure. And coming to the volume, so everything. So we can take the quantity which can be measurable is called physical quantity. The quantity which can be measurable is called physical quantity. I hope it is very clear. Now, so especially we are talking about scalars and vectors, right? So physical quantities are divided into two types. One is scalar quantity, another one is vector quantity. First we will discuss about scalar, then we'll go to the vectors. So then onwards, completely we'll talk about vectors. Okay, so very important, most important topic. So everywhere we will use this topic, vectors. Everywhere we will use this topic. Okay, so in the physics, so this like the points what we are discussing now, those points we will use to solve any problem or like that. Okay, so these points are very important. Whatever we are preparing, these points are very important. So concentrate on here. Right now, one is scalar. Second one is vector. Scalar is nothing but the physical quantity. Just now we discussed about quantity, physical quantity. Now we are discussing about scalar and vector. Scalar is nothing but the quantity which have only magnitude. The quantity which have only magnitude, it doesn't have direction. So suppose if you take mass, so mass, so scalar quantities are mass, scalar quantities, mass, volume, 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 speed, speed. Okay. So the quantity which has only magnitude, it doesn't have any direction. So that's why it is called scalar quantity. So scalar quantity example mass, volume and speed. Coming to the vectors, the quantity which have both magnitude and direction. The quantity which has both magnitude and direction, that is called vector quantity. Vector quantity. So vector quantity example. So displacement, vector quantity, vector, vector, the quantity which have both magnitude and direction. So example displacement, velocity, displacement, and coming to the second one is velocity, and third one acceleration also we can take. Third one acceleration, acceleration. Okay, so these are the vectors. So displacement, it has magnitude and direction. Velocity also same thing, and acceleration also same thing. Both magnitude and direction. The physical quantity which has both magnitude and direction, that is known as vector quantity. That is known as vector quantity. Coming to scalar, scalar is nothing but the physical quantity which has only magnitude. The scalar quantity, sorry, the physical quantity. The physical quantity which has only magnitude. The physical quantity which has only magnitude, that is called scalar quantity. So scalar quantity example mass, volume, speed. So coming to the vector, the physical quantity has both magnitude and direction. The physical quantity which has both magnitude and direction, that is called vector quantity. Example displacement, velocity and acceleration. I hope it is very clear. Now we will discuss about types of vectors, types of vectors, types of vectors. So here, observe carefully. Observe carefully. Observe carefully here. Types of vectors. Types of vectors. Equal vectors. So the vector whose magnitude and direction both are equal. The vector whose magnitude and direction both are vectors. Sorry, magnitude and direction both are equal. Magnitude and direction both are equal. Those are called equal vectors. Equal vectors. Coming to the negative vectors, the vector whose magnitude is equal but having opposite direction. Collinear vectors. So the vectors are acting in the same line. And coplanar vectors, the vectors are in the same plane. So the vectors are in the same plane. And co-initial vectors, the vector's initial point is same. The vector initial point is same. I am taking here. Initial point of the vectors is same. Localized vectors, the vector whose initial point is fixed. Localized means the vector whose initial point is fixed. Non-localized vector, the vector whose initial point is not fixed. Localized vector, localized, once again here, localized vector means the vector whose initial point is fixed. Non-localized vector means the vector whose initial point is not fixed. Zero vector, the vector whose initial, so the vector whose magnitude is zero. Magnitude is zero, that is called zero vector or null vector. So we can also take null vector, okay, null vector. So observe carefully, null vector also we can say. And coming to the unit vector, the vector whose magnitude is 1 unit, so 1, the vector whose magnitude is 1, that is called unit vector. Position vector, so if you want to represent the vector, so with the coordinate axis, so with respect to origin, so I am taking the vector here. So with respect to origin, if you are taking, that's a position vector. Okay, so OA I am taking. OA I am consider with respect to origin. That is a position vector. And the displacement vector also there. So here one more vector if you are taking. So the distance between initial point to final point of the vectors, that is called displacement vector. So now you can observe equal vector. So the vector whose magnitude and direction both are equal. Negative vectors. So magnitude is equal but are having opposite direction. Collinear vectors acting in the same line. So okay, same line. Coplanar vectors, vectors in the same plane. Co-initial vectors. So vector initial point is fixed. Okay, so vector initial point is same. So initial point of the vectors is same. Okay, that's why co-initial vectors. Localized vector, the vector whose initial point is fixed. So the vector whose initial point is fixed is called localized vector. So non-localized vector, the vector whose initial point is not fixed. Zero vector, zero vector is nothing but, so the vector whose magnitude is 0, or that is called null vector also. Unit vector, the vector whose magnitude is 1 unit, the vector whose magnitude is 1, so magnitude is 1, that is null unit vector. Position vector, if you want to represent a vector, okay, so with respect to coordinate axis from the origin, so origin we are taking from origin, okay, so how much it, so position, to represent the position of the vector from the origin. So we are representing, that is a position vector. Position vectors. I hope. So these are the types of vectors. Equal vector, negative vector, collinear vector, coplanar vector, co-initial vector. So localized vector, non-localized vector, zero vector, unit vector, position vector. So these are the types of vectors. Right? Next, addition of vectors. So there are three types. So addition of vectors. So we can add in three ways. That is, we'll discuss now. So addition of vectors, addition of vectors, addition. Addition of vectors. So addition, first point number one is triangle of vectors. Triangle of vectors. Okay. Second one is parallelogram vectors. Parallelogram law of vectors. And polygon law of vectors. Polygon law of vectors. So third one is polygon law of vectors. Polygon law of vectors. Okay. So triangle law of vectors, parallelogram vectors, polygon law of vectors. So triangle of vectors, if you are taking, triangle of vector is nothing but, so first one triangle of vectors I'll explain. Triangle of vectors. Triangle of law of vectors. Okay. So we are taking two sides, along the two sides of triangle. The resultant will be opposite to the, so the resultant will be taken in the direction of opposite to the remaining two vectors. So this, if you are taking a bar is a vector, b bar is a vector, and c bar is this one. Okay. So a bar, b bar, and c bar is the resultant. C bar is taking in the reverse of the AB. So a bar and b bar are both are acting in the same direction, along the same direction of triangle of two sides. Resultant will be opposite side. Resultant will be the opposite sides of opposite side of two sides of the triangle. Okay. So a bar and b bar acting the same direction. C bar is the resultant acting opposite to a bar and b bar. Right. Coming to the polygonal vectors. Polygonal vector also same thing. Okay. So similar to triangular vectors, but here, so all sides of the polygon will be taken in the one order. The resultant will be opposite to of remaining all sides. All sides. So that is the polygon law vectors. Polygon law vectors. Okay. So if I am taking here a bar and b bar, a bar, b bar, c bar, d bar, d bar, and e bar. So coming to the f bar is acting opposite to the a bar, b bar, c bar, and d bar. So this is the polygon law vectors. Polygon law vectors, triangle law vectors. So coming to the parallelogram. So parallelogram I will discuss little more. Okay. So in a clear way, I'll explain in depth related to parallelogram vectors. Now you can see. So we'll discuss about parallelogram vectors. So we'll discuss about parallelogram vectors now. Okay. So now you see. So two sides you are taking along the two sides of the parallelogram. Okay. So making certain angle. So here if you are taking. So this is the A bar and B bar are two vectors. Okay. Resultant I am taking here. So this is the resultant. So resultant I am considering. So this is parallel to this one. Parallelogram opposite sides are equal. So parallel. So I am taking one more here. Now you can observe. Okay, so this is the B bar. Now, if you draw the parallel to x-axis, I am taking like this, and y-axis I am considering like this. So this angle between this one is theta. So here also theta I am taking. This is x-axis and y-axis I am taking here. Okay. So now here you can observe. So A bar and B bar. So angle between A bar and B bar is theta. So this is the resultant R bar. Resultant R bar I am considering once again. So two sides you are taking along the two sides of parallelogram anyway. So parallelogram means opposite sides are parallel to each other. So these are equal. I am taking here A bar and A bar. So B bar and B bar. Okay. So if you take this right angle triangle, so from here cos theta equal to, what is the cos theta? Opposite side by hypotenuse. Opposite side by hypotenuse, that is x by b. So that is nothing but x equal to b cos theta. And coming to the y, so sin theta equal to, what is the sin theta formula? Opposite side by hypotenuse. Opposite side by hypotenuse. Opposite side is y and hypotenuse is b. So we are taking only magnitude. That's why I am taking. So here sin theta. Okay. So cos theta equal to, so adjacent side by hypotenuse. Sin theta equal to opposite side by hypotenuse. Right. Now, so y equal to b sin theta. Y equal to b sin theta. Yes or no? Y equal to b cos theta. X equal to b cos theta. Y equal to b sin theta. B sin theta. Now the resultant. So the resultant. So if you are taking the resultant, we have to take entire thing. That is, so r square equal to a plus x whole square plus y square. Okay, so you are taking the right angle triangle. So r square equal to a plus x whole square plus y square. Okay, so a plus x whole square plus y square. Right. Now we know. So from Pythagoras theorem we can take a resultant. Hypotenuse square equal to side square plus side square. Hypotenuse square equal to side square plus side square. Now here, so x equal to b cos theta, y equal to b sin theta. Substitute here. R square equal to, so a plus x is nothing but what is x value? X value equal to b cos theta b cos theta whole square plus y square equal to b sin theta. B sin theta whole square. We know a plus b whole square formula. What is a plus b whole square formula? A plus b whole square formula is a square plus b square plus 2ab. Yes or no? So what is a plus b whole square formula? A square plus b square plus 2ab. So a plus b whole square equal to a square plus b square plus 2ab. Okay. So a plus b whole square formula is a square plus b square plus 2ab. Right. So here also I am taking like the same. So now r square equal to a square plus b square cos square theta plus 2ab cos theta plus b square sin square theta, b square sin square theta. Now here b square cos square theta plus b square sin square theta is there, right? B square cos square theta plus b square sin square theta here. So we can take b square common. Yes or no? Now r square equal to a square plus, so b square I am taking common, cos square theta plus sin square theta plus 2ab cos theta. 2ab cos theta. So r square equal to a square. So we know sin square theta plus cos square theta equal to 1. Sin square theta plus cos square theta equal to 1. Yes or no? So from that we can take a square plus b square plus 2ab cos theta. Yes or no? Then r equal to root over a square plus b square plus 2ab cos theta. 2ab cos theta. Understood? So check once here. Check once. So parallelogram of vectors. Parallelogram of vectors. So the resultant, final resultant formula is this one. So here a bar, b bar are two vectors along the two sides of the parallelogram. So making certain angle between a bar and b bar is theta. Okay, so opposite sides are parallel to each other, so equal to each other. So if you are taking, so a bar, b bar, b bar. Okay, now so here you can observe some extending along x-axis and along y-axis. So along x-axis x, along y-axis y. So same theta I am taking here. Okay, so this angle only I am considering. Same theta. Now, if you are taking this right angle triangle, so if you are considering this one, right angle triangle, from this right angle triangle, cos theta equal to adjacent side by hypotenuse x by b, x equal to b cos theta, sin theta equal to y by b, sin theta equal to y by b, y equal to b sin theta, right? Now, so we know hypotenuse square equal to side square plus side square. Side is total we have to take, so we are taking the magnitude a plus x whole square plus y square. R square equal to a plus x whole square plus y square. Okay, so a plus b whole square formula, a square plus b square plus 2ab. Okay, and this identity also very important, trigonometry identity, sin square theta plus cos square theta equal to 1, right? So here r square equal to a square plus b square cos square theta plus 2ab cos theta plus b square sin square theta. Okay, so we from these two we can take b square common, cos square theta plus sin square theta plus 2ab cos theta. So r square equal to a square plus b square plus 2ab cos theta. R equal to root over a square plus b square plus 2ab cos theta. Okay, so those who have any doubts, so So I already given the Instagram link. Okay, so you can just check once my Instagram page. So my link is given, Instagram link. So if you have any doubts, you can ask. So okay, so if you like it, you can follow and share. So I hope so it is clear to you all, right? So if you have any doubts, you can ask me. So in Instagram, so you can check once, right? So I hope it is very clear to you, right? Yes. Now, so this is about addition of vectors. Addition of vector under that parallelogram vectors. Coming to the product of vectors. Coming to the product of vectors. So related to product of vectors, so we need to discuss little more clearly. So there are many points are there. So I will discuss about those points in the next class. Okay, so if you like the content, please do like, share, and subscribe to Student the Brand. So definitely product of vectors we need to discuss. There are many points are there related to product of vectors. Some problems also we have to do it. So in depth, I will take one more class so on product of vectors. So until now, if you like the video, if you like my explanation, please do like, share, and subscribe to Student the Brand. This is our Siva sir from Student the Brand. So thank you so much for joining and attending, listening the class. So my Instagram page is given, so you can go and check and watch my Instagram page. So if you like it, you can so follow, do like, share, and follow. Thank you so much. See you.